What is the purpose of chi-square test? There are three purposes. One is, it is used to test the independent or test of independence. Then test of homogeneity or test of distribution. Next is test of goodness of fit. So the goodness of fit, it is used whenever we use models, model fit. The homogeneity we will use when we use non-parametric chi-square. Now today we are going to use this test of independence. Test of independence. That is what we are going to use today. So let me tell again. Test of goodness of fit is used whenever we go for a model testing. Test of homogeneity or test of distribution is used whenever we go for a non-parametric chi-square. Now we are going to use test of independent. Independent, whether they are independent or associated. Okay. So now test of independence. Test of independence we can also call test of association. When it is not independent, which means they are associated. When they are not independent, then they are associated. So we can call it as a test of association. Now, chi-square, which is available in crosstab, is used to test whether there is a significant association between two variables. Now, very simple. Chi-square test is used to find out whether two variables are associated or not. Now let me tell again. Chi-square test is used to find out whether two variables are associated or not. Now, here we have to use both variable must be category. So, since it is a category based test, we can call this is a frequency based test. Since it is a frequency based test, is a non-parametric test. Non-parametric test. Frequency based test. Okay. Now hypothesis. Now, null hypothesis is because we are going to test whether they are associated or not. So, null hypothesis is there is no significant association between two categorical variable or two variables. Then alternate to that, there is a significant association between two variables. So null hypothesis is no significant association. Null, no. Very good. Now it is used to test whether they are associated. So now we are making statement. They are not associated. So hypothesis is statement what we make. So we say they are not associated. So we are starting with they are not associated and we are going to test. Very good. Now, very simple. Whenever we perform chi-square, we have to look at the significant value. We have to look at the significant value. If the significant value is less than 0.05, then we have to reject the null hypothesis. Simply, significant value less than 0.05, then reject the null hypothesis. Now, okay, now you have to tell in your mind. You have to look at the significant value. When the significant value is less than 0.05, we have to reject the null hypothesis. Everybody, you have to tell your mind. You have to look at the significant value. If the significant value is less than 0.05, we have to reject the null hypothesis. Null hypothesis, we call it as H naught. Now, okay. Okay, now, okay, so now we know chi-square. What we know? Null hypothesis. Okay, how many times? Okay, so now we know chi-square test. Chi-square test is used to find out whether two variables are associated or not. Right. Null hypothesis is there is no association. That's all. Now, let me go to the software. Let me do now. So this is the folder given to you. This is the folder given to you. Now, in the first one, we have first data set. We have savings. Now, let me open savings. Now, in this file, okay, let me describe what it contains. This file, or here, whenever we have a SPSS file, we call it as a data set. We will not call it as a file. We call it as a data set. This data set contains two variables. All right. The variable names are total income and total savings. Right. Look at the label. The label is used to write whatever we want to write. So in the name, we cannot write total space income. We cannot write. In the name, it will not take space, invalid character. But we want to give space so that it will be better. Only for that purpose, the label is given. In label, whatever you want to write, you can write. Now, see, when we do analysis, you will get a table. In that table, whatever available in the label, it will come in the column and row. So, write in such a way that you will understand how it should come in the table that you write here. If there is no name, then label, then whatever available in the name, it will come. Very good. Now, this data set, saving data set, contains two variables. They are total income and total savings. Now, what is the type of a variable? Type of a data. Now, here you can see both are ordinal. But some people, they will write wrongly because this is we have done. We should not get carried away by this one. We have to see the data. And we have to come to a judgment by looking at the data. Now here, so I have already written in my earlier PPT. So now when the options are given like this, now here 5 options are given in the questionnaire. In the questionnaire, total income or monthly income of your family, you have put like that. Then you have given a 5 option, you have collected the questionnaire. Then based upon take, you have given a value 1, 2, 3, 4, 5. Right. Now, what is this? See, we are giving so much importance to the significant value. Now, what is the meaning of this significant value? Okay, I'm not going to tell why this 0.05. That I will come later, probably today or tomorrow. But what is the meaning of significant value? I am going to tell now. Okay, it is probability of committing type 1 error. That is the meaning. Significant value means statistically it is the probability of committing type 1 error. Now, when the probability is less than 0.05, which means we are committing less than 5% error. 0.05 means 5%. Right? So, which means we are not committing any error. Simple. When the significant value is less than 0.05, which means the probability of committing type 1 error is less than 5%, which means we are not committing any error. Whatever we say is right. Simple. Now, what is type 1 error? Type 1 error is rejecting null when it is true. See, when it is true, we should not reject, we should accept. But if you reject when it is true, which means you are committing an error, that is called type 1 error. What is type 1 error? Type 1 error is rejecting null H naught when it is true. Okay, so that is the error. Rejecting when it is true is error, right? So, but if if it is less than 0.05, which means we are not committing any error. We are not committing any error because our error, if it is less than 0.05, when it is less than 0.05, which means when you reject it, you are not committing any error. That is the meaning, right? So our error is less, right? Whenever you reject, when it is less than 0.05, we are going to reject, which means we are rejecting. Okay, we are not committing an error, which means we are rejecting because it is false. That is why we are rejecting, right? So which means whatever we are doing is right, right? So now, when the significant value is less than 0.05, our error is very less, which means we are not committing any error. Okay, which wait. So now up to 20,000, 20,000 to 30,000, 30,000 to 40,000, 40,000 to 50,000, 50,000 and above, right? So we have given 1, 2, 3, 4, 5. Very good. So now we have given options. So we call it as a categorical variable. Now the one gentleman, he says up to 20,000 include 0 also. Okay. Now above 50,000 includes 2 lakh also. 2 lakh also. So which means the interval, equal interval we cannot pursue. Then apart from that, please understand, we said for a ratio, we can find out meaningful mean, right? Ratio data, we can find out mean. Mean means, for example, if you get 25,000, we can say the average income is 25,000. Now, let us look at the data. 4. What do you mean by 4? It means he is in the 4th category. Now, what is 2? He is in the 2nd category. Now, if I find out the mean, what result I will get? I will get probably 2.8 or 3.2. Can we say it is 32,000? We cannot say. That is why it is a ordinal variable, because 4 is greater than 2, 3 is greater than 2. So it is a ordinal. Now we are not worried whether it is ordinal or nominal. It is a categorical variable, right? So now let me see. These are all the way we have to find out. Now here options are given. So for option 1, 2, 3 given. So we will get to the mean for 1, 2, 3. So we will not get a meaningful result. So it is a categorical variable. Now here also we are given option. So it is also categorical variable. Symbol. So now we know that both are categorical variable. Now we already memorized in our mind. When both variables are category, we have to use chi-square, right? So this thing, it should come to your, even when you sleep, it should come, right? Both variable category, we have to use chi-square, right? Very good. So now we know we have to use chi-square, right? Now, how we have to use chi-square? I have already told you, all analysis is available under analyze. So I'm going to analyze and save descriptive statistics. Under descriptive statistics, I cross tab. All right. So that is why whenever I have put a presentation, I have written like this, right? What I have written, the cross tab chi-square. I have written, right? Chi-square is available in the cross tab. Is used to test. That is right. So now we are going to use the cross tab chi-square. So analyze descriptive statistics. I'm using cross tab, right? What do you mean by cross tab? Cross tabulation. What do you mean by cross tabulation? What do you mean by cross tabulation? Cross tabulation means one variable will be in row, another variable will be in the column. That is the cross tabulation. What is cross tabulation? One variable will be in row, another variable will be in the column. Now we can put, let me put row total income into the row and total saving into the column. All right. So now what I have done? Analyze descriptive statistics, cross tab. I have put one variable into the row, another variable into the column. Now I am not going to touch anything. Hello. Hello. Okay. So now, okay. Okay. So now I put total income into the row, total saving into the column. Now you know what is row? Income in the row, savings in the column. Now let me say okay. Now result. Now this is the result. This is the result, right? So this result I am having in the PPT, right? So now let me show the PPT. Okay, let me show the. So now we have put total income into the row and total saving into the column. Now we are getting this output. Okay, we have put savings into the column. So we had 5 category up to 5,000, 5,000 to 10,000, 10,000. All right. Then income row up to 20,000, 20, 30, 30, 40, like that. Now, what is the meaning of this 67? What is the meaning of this 67? The 67 people frequency number. 67 people are having the income of up to 20,000 and having the saving of up to 5,000. So this is 67. What is 42? 42 means 42 people frequency. 42 respondents. They have an income of up to 20,000 and a saving of 5,000 to 10,000. This is a cross tabulation. This is a cross tabulation. Now, can we say now more income people they save more? Whether we can say like that? From the cross tabulation, it is little difficult to tell. Okay, so now this says that income and saving, how many people are there in each income and saving category. We cannot come to a conclusion whether more income people they save more or less income people they save less. Such conclusion we cannot come. That is why we are going for a test. Test to find out which income category is associated with which saving category, like that. Only for that purpose we are going to use the chi-square test. Okay, so now we know what is cross tabulation, right? Now I am going for a chi-square test, right? So now let me go to the software. Now here again, analyze descriptive statistics, cross tab. Now I have put total income into the row, total savings into the column. Now I want to have chi-square. Where is it available? I am searching. Oh, now if at all we want to perform any statistics, there is icon by name statistics. I have to go there. If at all we want to perform any statistics, we have to go to the statistics icon. Now click the statistics. Then I am having this chi-square. Let me click this chi-square. Then let me go here. Now if I click it, now what I am getting in the result? I am getting a two output. What are these two output? One is a cross tabulation output, another is a chi-squared output. See, now what is the extra we are getting? This chi-squared test table. So which means whenever you click the chi-square, you are getting this chi-squared test table, which means this is the information available for the chi-squared test, right? So now let me take this chi-squared test table, same table 128.683, same table. Let me go to the PPT. Now let me go to the PPT. Okay, so now, okay, before going to this, okay. Okay, this is the output. Yes or no? Right. This is the output we have. Right. Now, before going to perform any test, okay, so what we have to do is, okay, we have to look at the, I have already told you, we have to look at the significant value, right, after performing any test. Whether it is a chi-square test or ANOVA or correlation or regression or SAM or ARIMA, ACHI, KACHI, whatever you perform, you look at the significant value. If the significant value is less than 0.05, then reject the null hypothesis. Okay, so significant value, reject the null hypothesis, right? So I am putting another second time again and again. Now it should be in your mind. Please keep it in mind. We have to look at the significant value. If the significant value is less than 0.05, we have to reject the null hypothesis, right? So we have to see the significant value, right? So now, see, this is the output, right? So in the output, we have many. So our eyes should search the significant value because we have stated that we have to see the significant value. So now, normally I used to give many examples for this one. Say, for example, when Dronachari, he has taken their biggest disciple, he has asked everybody, what do you see? They said, I could see the tree, I could see the bird, I could see the tail, I could see this one. But Arjunan said, what do you see? I'm sorry, I could see only the eyes. Okay, then he has asked hit. He has hit the eyes, the bird has fallen. Alright, if we have seen the tail, if we hit the tail, the bird will fly. So we have to hit the eyes. So the I is nothing but our significant value. I is nothing but significant value. Okay. Now see, for example, I used to tell some more example also. Now, whenever you go for alliance, okay, the girl is coming. What you will see? We have to look at the face. We have to, oh, the girl is good. Okay, so now in Tamil Nadu, Mohan Sundaram will see the face and he will decide. In Kerala, what you will do? You will see the face and you will decide. Even if you go to America, what you will see? You will see the face and decide. So, whether it is a chi-square test, whether it is ANOVA, whether it is SAM, we have to look at the significant value, we have to decide. Now, I hope everybody might have understood this one, right? Now, I know that I have to see the significant value. What is the significant value? This is the chi-square test. In this chi-square test, I am going here, I am going here, I am going here. This is the significant value, right? Now, the significant value is 0.00, right? So, which means it is less than 0.05, which means we have to reject the null hypothesis. All right. So, now let me see what I have written. Okay. So, now this chi-square value 128.683, that is called the calculated value. The calculated value is 128.683 and its significant value is 0.000 and the degrees of freedom is and at degrees of freedom of 16. Okay. Now, since the significant value is less than 0.05, then reject the null hypothesis and accept the alternate hypothesis, which means no. Now, what is null hypothesis? No association. No association is rejected. Null alternate hypothesis, there is an association is accepted, which means there is an association between two variables. Hence, it is concluded that there is a significant association between total income and total savings. Now, this is an interpretation by looking at the significant value. Now, this is an interpretation based on the table. Now, finally, what you tell, that is called inference. That is called inference. What is the inference? It can be further stated that savings, because both are associated, right? Savings depends upon income. Savings depends. This is what you state. This is what you state from the interpretation. Now, for the inference it should come from the minds of the researcher. So, for giving inference, only the researcher can do. Interpretation, anybody can look at. Anybody can tell based on the table. But the inference, only the researcher can do. Okay, so this is what you have to write.